Graders is Newton's third law worksheet, and it should help get you guys ready for the modeling quiz that you guys will be doing at the end of this chapter, the collision between the ACM collection pod the asteroid collection pod and the space station. So kind of up to this date, we know that the thrusters fired normally, but the pod was heavier than normal because it had picked up more asteroid samples. So when the thrusters fired, it only slowed the pod down. The pod kept moving, it hit the space station, and what we're going to be really focusing on is that moment where the pod is hitting the space station in that collision force. Okay, so for your guys' for your learning targets for today, I can model the force between two objects in a collision. So you guys are going to look at objects of the same mass, which are a little bit easier to predict, and then objects of different masses, which can be a little bit trickier. But what you guys should be able to see out of that is anytime we have a collision between objects, those two objects are going to exert an equal force on each other, no matter their size, but in an opposite direction. And then I can use mass to explain why two objects in a collision have different changes in velocity. So it's not necessarily the force you see, but what we tend to see is what happens afterward. And sometimes that's really easy to get mixed up with force. So if we have a bug colliding with a car windshield, okay, believe it or not, they put the same force on each other, but because that bug is so small in mass compared to the car, we're gonna see a way greater effect for the bug than we are for the car. In fact, it probably won't even change the velocity of the car at all, but it definitely changes the velocity of the bug and that fate of that poor bug. All right, so at any rate, let's move on to your bell ringer. You guys have two objects, both of the same mass. They're colliding with each other here. It looks like they're both going the same velocity towards each other. So describe the force during the collision. Both pucks are the same mass. So either A exerts a greater force on B exerts a greater force on A, or both forces are equal. Okay, this one, same thing. We've got two pucks that are the same, except A is at rest. B is moving with a kind of large velocity to the left towards puck A. So when those two collide, what does the force look like? So A exerts a greater force on B exerts a greater force on A. Both forces are equal. Okay, this one, now we're switching up and doing two different masses. So A is our lighter puck. It's only 1 kilogram. B is 20 kilograms, so significantly larger. Okay, when those two collide, they're both moving towards each other. What does their force look like? Okay, then we've got A as the larger puck here. It is 1 kilogram. B is only 0.25 kilograms, so a quarter of that. Okay, A is at rest. B is moving to the left. So when they collide with each other, what does that force look like the moment they're touching? Not what happens after, but the moment they're touching. So go ahead, take a second, pause this video if you guys need, and then come back to this video when you're done answering those 4 questions on slides 2 and 3. Okay, so we're going to do a little sim practice to help you guys kind of get in the right mindset. So the first thing you guys are going to be doing is objects of the same mass. So in the sim, here's your guys' link to the sim right here. You're going to right click that whenever it decides to pop up for me, and you guys are going to open the sim link. You're going to forces that act on objects of the same mass, okay, during a collision. So again, as part of the sim, you guys are doing objects with just the same mass, okay. Set up 3 different collisions. So again, all of your different collisions could have objects of the same mass. It doesn't matter which mass you use, as long as when those two objects collide, they have the same mass. Okay, you may set the initial object's velocity as like whatever you guys want it to. You can have one at rest, you can have them both coming into each other, you can have them chasing after each other. It does not matter as long as those two objects that are going to collide and that they have the same mass. So for each of the 3 collisions, go to Analyze, screenshot the collision showing the 2 pink force arrows with the force of the collision in newtons. So you're going to go to Analyze, you're going to go playback on that video, and you're going to find the point where they connect and show the pink arrows and the size of the force of those pink arrows. Then you're going to copy and paste 3 different collisions onto the next slide. Again, 3 different collisions. And then once you guys are done with that, use your draw tool to circle the object that had the largest change in velocity after the collision. If they both have the same, you're just going to circle both of them. Okay, so let's take a look at what that might look like. It really, again, does not matter what objects I use, but whatever you choose, use the same. So maybe I have 2 of the 20 kilogram. Okay, and then again, I can choose whatever velocity I want. I want this one going Mach Jesus speed to the right. This one maybe is just gonna be going a little bit. Again, it doesn't matter as long as these 2 objects collide and they're both the same mass. So again, doesn't matter what mass I choose, doesn't matter what velocity I have, as long as they will eventually collide and you can see that collision and that they are the same mass. Okay, so I'm gonna go ahead and hit run. and watch what happens. Okay, and then when I go to analyze, I should be able to grab my little blue slider here and scroll back to the exact point where they're colliding, and I get those pink arrows. Okay, so I'm gonna screenshot this. I don't have a Chromebook, so I'm gonna use my snipping tool. And what I'm gonna screenshot is just kind of this little part where they're colliding. I can assume that the arrows are over here and over here. So I'm gonna go ahead and copy that into my next slide. So that's gonna be one of my examples. Okay, you guys are gonna do 3 total examples as well. Remember that with a Chromebook, in order to screenshot just the little part where it shows them colliding, you guys are gonna hit Control-Shift and then the little square key with the 2 arrows to the right, or the 2 lines to the right, right above the 6 key. And then you can click and drag just the part that shows the pink arrows of them colliding and the values in those newtons. Okay, so you're gonna go ahead and put 3 different screenshots in there. My computer is taking a while right now, so it doesn't seem to want to add my screenshot in for me. So hopefully you guys have better internet than I do right now. Okay, once you guys have all 3 of your screenshots, you're going to answer this question on slide 6. Look back at each of your 3 screenshots. What 2 observations do you notice about the 2 arrows in each of your collisions? Okay, so again, take a look. Again, think about Newton's third law and what Newton's third law says. And that should help you guys think of your 2 observations if you guys are having a hard time coming up with those. Okay, so go ahead and then you'll answer this question as well on slide 7. In your 3 collisions with the objects of the same mass, you should have noticed the same change in velocity for each collision. Again, because that's the same mass. While some objects may have started moving, stopped moving, changed direction, sped up, or slowed down, they all did so by the same amount. Why is that? So think about why they all kind of had the same change. Again, when I say change in velocity, I'm not meaning they do the same thing. But if I look at my sim again and look at the change in velocity, okay, this one slowed down by 9, this one sped up by 9. So even though they're not doing the same thing after the collision, they still had the same change in velocity. Okay, so answer that question here. Once you guys are done through slide 7, you guys can unpause this video. So take a second, pause the video, complete through slide 7, and then when you'll come back, we'll talk about objects with different masses. Okay, objects with different mass. In the sim, you guys are going to do the exact same thing, except you're going to choose 2 objects that always have different masses and that will eventually collide. Again, you can set the initial velocity for them. You can choose the objects as long as they have a different mass. And then you guys are going to do the same thing. You're going to screenshot the collision showing the 2 pink force arrows. So if I choose, let me see, go back to build, I'm going to rebuild, and I'm going to do maybe a really, really heavy object, and I'm going to have it, I want to move it really fast. Okay, and then my other object I want to be really, really light, and I'm going to have that one just be at rest. Again, it doesn't matter. You guys can choose as long as they're going to collide and that they're different masses for this one. So then I'm going to go ahead and hit run, and then hit analyze. Okay, and then I can be able to see, all right, if I scroll back, where's my force? Okay, so I want this kind of screenshot right here that shows my force. I'm going to screenshot that with the pink arrows. And then I'm going to look at my change in velocity. So it looks like object A, which was my lighter of the 2 objects, had the larger change of velocity. So when I screenshot that on the next slide, okay, make sure you guys circle object A or whatever was your lighter object that had the greater change in velocity. So if you guys didn't circle on the last activity with the same mass, make sure you guys do so. Remember, if it has the same change of velocity, circle both. Okay, so on each of your 3 screenshots here, you guys should circle the one that had the biggest change of velocity. Again, look at your analyze to see that change in velocity. Okay, all right, and then you're going to answer the same 2 questions. Look back at each of your 3 screenshots that show the pink arrows. What 2 observations do you notice about the 2 arrows in each of your 3 collisions? Again, if you're struggling with this question, think back to what Newton's third law is, check your OneNote, whatever you guys need to do to kind of refresh your memory on that and kind of help you predict what those arrows should always look like. Okay, in your 3 collisions with objects of different mass, you should have noticed different changes in velocity for each collision. While some objects may have started moving, stopped moving, changed direction, sped up, or slowed down, they all did so by different amounts. Why is that? So what we saw in the first sim part of the activity is when they have the same mass, we saw the same change in velocity in our analyze. Okay, so we saw the same number here and here, versus right now we're looking at different masses, so we have a really significant change in velocity for these 2 objects. So why is that? What's different about these 2 and how might that contribute? Okay, all right, once you guys need to, so pause finish up through slide 11, and then when you're ready, come on back and I'll show you guys the last part of this, which is your modeling. Okay, so we're going to be doing this modeling, and again, this is going to help you guys get ready for part of your assessment for chapter 3 over Newton's third law. So on the following slides, model the given force that occurs during a collision, or I might ask you guys to model the velocity change after the collision, or I might ask you to do both. If it helps, use the sim. So here's a link to the sim right here to help you guys kind of figure out. Now, keep in mind, this isn't going to be black and white. You guys are going to see kind of some gray areas, and it's going to be a lot of prediction. So when we go over the answers to this, you guys will kind of not have an exact answer key, but you'll have a general guideline for your answer key. I don't know if that makes sense, but I'm going to do 2 examples with you guys to get started. If you guys do decide to use the sim though, you guys can use a 0.5 kilogram puck as your small puck, 1 kilogram puck is your medium, and a large puck could be the 2 kilogram puck. And then your velocities could be 1 centimeter for small, 2 centimeters per second for medium, and a large velocity could be 3 centimeters per second. But again, your sim isn't going to give you a black and white answer. Okay, so in the during force box, use the pink arrows. So I'm going to kind of see this color coordination right here and say, all right, I need to do the during force. Here's my pink here. I need to do the pink arrows to model the collision forces. Okay, so this is my first example. I've got 2 small objects, so they're both the same size or same mass objects, both moving at each other with a small velocity. So when they collide, I'm going to model my forces, and then I'm going to see that they kind of swap velocities here. They're going to have the same change in velocity, and they're both going to move away from each other with a small velocity. So to model my force for that one, I'm going to choose 2 small arrows. Again, it doesn't matter if I choose small arrows or medium arrows or large arrows. I'm going to kind of just guess small because they're moving at a small velocity and they're a small object. But what I should see is that those 2 arrows are in the opposite direction, okay, and they're the same size. Okay, so there is really, you shouldn't have 2 different size arrows on any of these. Okay, so keep that in mind. That's a pretty big hint for you guys. So that's the first one, that's the example. And then example or question number 1 I'll also do for you guys. So again, 2 medium-sized objects, so they're both the same mass. First object's moving to the right with a medium velocity. This one's at rest. And then after they collide, we're going to see this one start moving with the medium velocity to the right, and this one's going to stop moving. Okay, for this one, I'm using the during force, so I'm going to use the pink arrows. Again, it really doesn't matter what size arrow. I'm going to say logically, medium's going to make the most sense to me because they're medium objects and they're moving at about a medium speed, so I would say about a medium force is accurate. So when they collide, they're going to hit each other with medium force going in opposite directions. So both of those will be medium force. Okay, so you'll go ahead and work through these examples. I want to do one more with you guys that show opposite mass. So if we scroll clear down to slide 20, number 7, we've got a medium object hitting a small object. This is coming in a medium force. This is at, or excuse me, medium velocity. This small object is at rest. And then I'm going to do both the during force and the after force. So what happens to those after? With this one, I'm going to go ahead and just kind of guesstimate and say, I'm going to think it's a medium force. But again, even though these 2 objects are different sizes, they're going to hit each other with the same force. Okay, so you guys could have chose a small force, a medium force, or a large force. But what matters is that those 2 arrows are the exact same size no matter what. So the medium's putting a medium force on the small object. The small object is also putting a medium force back on the medium-sized object. So those 2 arrows are the same size but in opposite directions. Okay, afterwards, if I look at modeling the after force, we're going to see a greater change in velocity for the small. So it was at rest, and now maybe it's speeding away with a large velocity to the right. This one was moving with the medium speed. Maybe it only slows down to a small speed. Okay, so that's kind of going to be what we're looking at with these different ones, is that when we have the more massive object, okay, we're going to see less of a change in velocity. So this only went from medium to small, both moving to the right, whereas this one was at rest and is now moving at a large velocity because it is the lighter mass. Okay, so go ahead, complete the rest of these modeling tools. When you are done, okay, go ahead, do your exit ticket, and then make sure you guys look through all the slides, check your answers, check everything before you turn it in. I hope you're having a great day, and I'll talk to you soon.